Okay, I want to show you one of the list features out of Python that I really like and use a lot, and that's list comprehensions. In the book, it's covered in one little subsection and not in very great detail, but we're going to cover it a little bit more. Now, this is one of those features that I wish I had in other languages, so this is a pretty special thing. And the only other language that I know that implements it very well is Haskell, which is a pure functional language. So let's take a look at list comprehensions in Python. So I'm going to start out with my original list. I've written a short program, 19 lines here, just to play with list comprehensions, and we're going to introduce some new concepts here along the way. So this is one where, this is going to have a bunch of different things going on. Let's get a little bit more output room, and the first thing is we're going to start out with the same list we had before. And then on line 3, we have our first list comprehension, and I'm going to pick out all the values that are less than 10. In our quick sort example at the very beginning, we had 2 list comprehensions. We picked a value, then we found the ones that were less than and the ones that were larger than. And this was actually done in line. So here we are looking at our list comprehension and seeing how this works. So we're going to find all the values that are less than 10. Now, 10 is not less than 10, so it shouldn't be in that list, and 20 shouldn't be in that list. Let's run the list comprehension, and you get this funny thing, list comp, which actually behaves as if, it has an entire different... You notice how up here we have the global frame, and down here we have a whole new frame as it's building this list comprehension. Under the covers, what the language is doing is it has written a program for us based on that list comprehension. As I'm clicking through here, I keeps changing, and it's actually going to build that program and return the value of the list. So here it is finally with a return value. It's written a function for us, and there finally is L2 with the values for that list. And let's see, all of those are less than 10, and if you look carefully, you'll see that yes, 20 and 10 are not included in that, and it has worked correctly to pick out the values that are less than 10. So this is a way that you can take a list and you can say, I want to run down through this list and I want to get a criteria on what's going on in this list. And I want to pick out stuff and filter the data that I have. And when we look at things like sorting and searching, between the sorting and searching, this is half of all compute power that's used in all computers in the world, is sorting and searching. So here we are looking at the search side of lists, whereas before we played a little bit with sorting it. And we're going to get to some combinations a little later where we're going to combine sorting first and then searching to make searching efficient. But here's a way to go through a list and filter out the pieces that you need. And sometimes that's all you need, is you just need to say, okay, I've got this big list of data, I've got a criteria that I need to match, let's pick out those pieces and get those pieces back. Now, you can do more things with list comprehension. The next one, I'm going to take that list, and you'll notice that it has I times I. That's the square of I. There's another way to do that. You could say I star star 2. But here is, and the star star operator is exponentiation. So you could get the cube of I as well. You could say I star star 3, and you could cube it. But here we're just going to multiply I times I for I in list. And when we do this, again, it's going to turn around and it's going to implement one of these list comprehension functions for us. And as we click through it, you'll notice that it has I and it's showing you what I is in each case as it's going through that. And it's building a list for us. So you'll notice that it's actually showing us the values as it's going through. Here it is with 10 for I. And it's building up that list as it's going along. And eventually, yes, we have a return value, which is the squares of all of the values in our list. And 20 squared, 20 times 20 really is 400. So this gives us a way to do calculations on lists in a single line and manipulate an entire list and create a new list. So we'll print that one out. And yes, we've squared a list. Now here's a completely new thing. There's a range operator, and range allows us to produce a series of integers, basically. And you'll notice that on our list, they all have subscripts like sub0, sub1, sub2. That is really the use of things like range, is we can like get to the pieces and we can walk through individual pieces of a list. But in this case, I just want to take range, and I'm introducing a couple new things here. There's range and a for loop, and we're just going to print out what happens when you run a range. Now, this is our first loop that we're going to mess with in this language. And you'll notice it goes from line 9 down to line 10, and it says, am I done? Nope, I go back to the top. So I can iterate. I can go over and over a set of things. And whenever you have a for loop, that's what's happening, is it should be going around and around and around doing things. In this case, it's just printing out I. And I is just this range. So I'm expecting the next one is going to increment I, and we're going to get 1. Now, an important concept here, and we're going to come back to this concept, is for you to learn patterns in how you code. And this for I in range is one of those patterns in Python. And there's going to be a series of these patterns. And I'm going to show you a pattern and say, for this kind of a situation, you want to use this kind of a pattern. A large portion of what I do in programming is, okay, I've got this memorized pattern, I've got this situation, the situation matches with this kind of a pattern. I just like blitz type in that pattern, and I've magically written a piece of code. So here is your first pattern. Now, I use those patterns for things like the list comprehensions too. But this is a good example of a pattern, and we're going to have others. But here's what this pattern does. It just goes around and around this number of times, and it's going to print out the numbers. Now, notice it stops at 4. So a range like this, it went to the next line, is 0 through 1 less than whatever the ending value for the range is. And there's more things you can do in ranges. The reason I wanted to show you a range is because now I'm going to use a range in a list comprehension. Instead of having a list of 10 values, I'm going to have a range. And what would the range be? It would be 0, 1, 2, right up to 9. So if I do a list of 10, for I in range 10, then I'm going to end up with a list of 10 values. And they're going to be 0 through 9. And if you look over here at I, you're going to see that I is counting up very nicely, 2, 3, and I'm going to click real fast and get up to 9 and get the return value, and there is my list, built quickly and easily with a range. We're going to come back to lots of other things having to do with loops, and a loop isn't the only way to produce that, but here we go with a nice list. And then I want to be able to square all the values from 0 to this ending value. Now that I've got a list, here's my exponentiation operator, I star star 2 instead of I times 2. And I can just sit here and say, okay, we'll just build a list comprehension. And we'll just square the values that we've created. And again, I'm going through each one of those values up to 9, and there's a list. 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, right up to 9 times 9 is 81. And it returns me, as that list comprehension, the square. Now, you can do fancier things with list comprehensions. We'll go back to the original list. Remember, it had 2, 4, 20, this list up here at the top, and we're going to use that list in a list comprehension and say, I want the word even. Okay, and I'm going to explain this if piece here, but it says, if it's even, I want the word even, else I want the word odd in a list of strings. So I'm starting out with a list of numbers and producing a list of strings. Again, Python writes me a program that does this for a list comprehension. And now you notice I is going 2, next one will be 4, 20. These are the values out of the list in the order in which that original list is. So I'm evaluating the values for being even or odd. And as I go through, suddenly I build a new list, and that new list at, say, position 4 says it's even. If we look up here at 4, we see there's a 0. And I usually think 0 is an even number. And it's a special case, but yeah, it's even. And the order of these evens and odds matches with my original list up here. So 4 at position 0 is an even number. And 3 at position 6 is an odd number. So we've built a list of the words even and odd out of a list comprehension and an original list. Now, before we go on, I've used this operator percent, and I think you did this operator in the homework with generating 8s, where you did something like 16 mod 2 equals 8 and printed it out. That percent is the remainder of division. Now, if I take division and I divide by 2, let's say 3 divided by 2 is equal to 1. 1 is equal to 0 is false. That gives me the else, and it produces an odd. If I look at this in the other way, as in I being 4, okay, because we're at the very first thing in the list, at the 0th thing in the list, 4 mod 2, well, 2 goes into 4 2 times with a 0 remainder, so this percent gives me a 0 here. 0 is equal to 0, that's true, and we get even. Now, pay special attention. You notice this is not an assignment equals here. This is equal, equal. And that's really important. This is how Python differentiates between a comparison to a numeric value and an assignment of a value. And you wouldn't be able to assign to I%2 anyhow, but this is how it tells the difference. And there are a whole slew of programming languages, like Java, C, Go, Python is in that list, that all use this nomenclature of the double equals means a comparison and a single equal is an assignment.